This is Mr. Craig, and the purpose of this video is to discuss limiting reactants. As you can see from the questions here, this is from the notes, or actually from one of my lectures, examples, which is from day 14, which was the limiting reactants lecture. Let's get right to the questions. Question number 1 says, determining the limiting reactant when 55 grams of methane reacts with 22 grams of oxygen gas in a combustion reaction. Now I put a side note on here. Hint, we're not trying to calculate how much product was formed. This technique, which I'm about to discuss, must be able to be demonstrated on the AP exam. Now I know that some of you have been taught how to do limiting reactants by taking each of the reactants and finding out how much product was formed and then comparing the two answers of how much product was formed. It's not a bad idea or bad technique in general chemistry, but in AP chemistry there are specific questions asking just about the limiting reactant. And it's not a real good practice to get into by calculating a product when you're answering a question that's not being asked. However, in this first question it's asking, determine the limiting reactant. You have two reactant amounts. You know that you are to do a limiting reactant problem when you see that, number 1, you have two reactants, and number 2, you have an amount for each of those reactants, whether it be in grams, kilograms, moles, molarity, volume, different scenarios which will play out throughout the year. But if you have amounts for each of those reactants, you have to determine which one of those will run out first. In other words, the one that doesn't run out is considered to be an excess. The one that is completely consumed within the reaction is considered the limiting reactant. Like in this example here where we have methane. If we have methane right here and we react that with oxygen, if one of these runs out, there's no way we can make carbon dioxide or water over here. It's just it's too difficult. Well, it's impossible. Okay, so what we need to do is simply pick one. It doesn't matter. Pick 55 grams with the methane or 20 grams of the oxygen. So we're going through our 4 steps of stoichiometry. Step 1, write a balanced equation. I've already done that for you. We've got the methane reacting with the oxygen, which always produces carbon dioxide and water. Make sure that we balance not only the formulas, but also make sure that we have the correct coefficients. Again, I like writing the information above the compounds in this case, so that I don't have to go back to the question and start looking within the question what was given. I'm going to go ahead and start off with the methane. It doesn't matter. You could pick either of them. So in the limiting reactant step, what I've done here is I've started off with my methane, which is step 2. I need to change that into moles. So take the 55 grams of methane, convert it into moles. Molar mass is on the bottom here. So I got 1 carbon and 4 hydrogens, and these 2 right here actually are my second step, converting what's given to moles. Step 3 is I need to get rid of the mole amount of the stuff that I started with. But one thing I want you to notice, within my mole ratio I have moles of methane on the bottom, that's what I started with, and then I have moles of oxygen on top, my other reactant. I'm not going to put a product amount in there. The question's not asking how much of a product was formed. Besides, I don't know who's going to run out first. So I want to compare the 2 reactants to each other. So go ahead and put in my coefficient or my correct mole ratio. And then, since it's asking, or what was given in the question is 22 grams of oxygen, I don't want to stop with moles, but I want to go one more step and convert or change this back into the same unit of the information that was given. I don't want to stop with moles. I can't figure out how many moles I have, but I can definitely find out how many grams I would need for this complete combustion reaction. So once I do all the calculation here, I find out that I would need 219 grams of oxygen. What does that mean? This is where a lot of students have trouble, because they do the calculation and then they just stare at the problem and they wonder, what have I just done? Well, here's what you need to do. You need to talk yourself through this. Here's how you do this. You say, if all 55 grams of methane are reacted and completely consumed, I'm going to need at least 219 grams of oxygen. The question you should ask yourself is it possible for all 55 grams of the methane to become or get consumed? Well, I would need 219 grams of oxygen. I only have 22. So, based on this information, who is the limiting reactant? If you said methane is your limiting reactant, you are correct. Here's the rationale, and you need to talk yourself through this. If I use all 55 grams of methane, I'm going to need at least 219 grams of oxygen. I don't have enough oxygen to completely use up all the methane. Therefore, since I only have 22 grams of oxygen, I'm going to run out of oxygen well before I have a chance to run out of methane. Therefore, my limiting reactant is methane. Okay, so again, here's my statement. If 55 grams of methane is completely reacted, you would need a minimum of 219 grams of oxygen. You don't have 219 grams of oxygen. Therefore, oxygen is your limiting reactant.